This lecture will be on the structure of the atom from chapter 4.2. Be able to define electron, that's a negatively charged subatomic particle. Proton, a positively charged subatomic particle. Neutron, a subatomic particle with no charge. And nucleus. I'll leave that one till later in this video. Compare atomic models of Thomson and other scientists. Identify how waves travel in cathode rays. Identify the placement of electrons in an atom, and this is going to vary between the models. Identify experiments that were essential to developing each atomic theory. J.J. Thomson created something called the cathode ray tube. What would happen would there be a positively charged substance that would be heated, and you would have subatomic particles come off of this. An anode, or negatively charged area, would cause these subatomic particles to bend as they traveled through a near vacuum. You could actually see these particles as they traveled, and being able to see the particles was the cathode ray. It looked like a ray of particles moving. And you could deflect these particles to determine what the charge was. And this beam that could be seen and deflected meant that there was something in the atom that was negatively charged and was something smaller than the atom, hence negatively charged subatomic particles that we call electrons. He called them corpuscles and hypothesized that they were being emitted. The charge, as he found, did not depend on the type of gas in the tube or the type of anode. As long as it was negatively charged and as long as there was gas, you would see a cathode ray. Thomson's model is the plum pudding model. He knew that there was something in an atom that was negatively charged. These corpuscles, or electrons, were part of the atom and were something that could be identified. He could not identify the positively charged things, and said there would be a positively charged matter and electrons embedded in it. Some other experiments were done that were to determine what was actually in the atom and the other parts. A scientist named Robert Millikan carried out experiments to find if these electrons were charged and how much they weighed. This is a YouTube video that you can link to look at the oil drop experiment, where he actually could weigh each individual electron. Eugen Goldstein would discover that there was a proton because in this cathode ray, there was actually something traveling the opposite direction, and that meant that there were positively charged particles. He found the mass of these and found that they existed as well. James Chadwick would later confirm the existence of the neutron. So these experiments found the other parts of the atom. Now, Rutherford was Thomson's student, and he wanted to know if this plum pudding model, where electrons were embedded in the atom and were kind of a solid thing, was true, or whether that there was a space in the atom. He hypothesized that there would be space in an atom and that some things could pass through this space. He used alpha particles, which are something that is emitted during radioactive decay, and these have a positive charge. What he expected would be that alpha particles would pass through a very thin gold foil as they would pass through the spaces between atoms and as they would pass through the electron cloud, as he hypothesized. But what he saw was not only that some of these were deflected, but that some of them bounced straight back at the beam. And this was the nucleus. So he hypothesized that within the atom there is a small area that contains the protons and neutrons that would be the nucleus of an atom. Now, to think how small, if you had a pea sitting in the middle of a football stadium, that pea would be the nucleus and the football stadium would be the electron cloud around it.